we will look at the relationship between radians and degrees. Well, to give you the answer up front, we know that pi radians is equal to 180 degrees. But how does this happen really? I'm going to give you a very simple mathematical explanation for this relationship. First, I'm going to need two circles. All right, so here are my two circles. Let me assume that the center for the small circle is somewhere here and the center for the large circle is somewhere here. Of course, those two circles have different diameters. Let me show the diameters as well. Let me draw a line like this through the center for the small circle, and I will assume that the diameter for the small circle is d sub 1. I will show a diameter for the larger circle as well. Let me assume that the diameter for the larger circle is d sub 2. All right. What can you say about the circumferences? Well, the smaller circle may have a circumference, let's say C1, and the larger circle may have a circumference, let's say C2. What can you say about the relationship between the diameter and the circumference? Well, I will let D be the diameter technically for any circle, and I will let C be the circumference. We know that the circumference, according to this explanation, circumference C should be proportional to the diameter, because if you increase the value of D, of course, C should be large. Therefore, I can say that C is proportional to, here's a symbol I can use for the proportionality, C should be proportional to D. Let me write the meaning of this symbol in words. It looks like Greek alpha. I used that one to say proportional. Of course, there's another popularly used symbol also for proportionality. You can use 4 dots like this to say two quantities are proportional. For this explanation, I will stick to alpha for the proportionality. So what does it mean? What does it mean to say that C is proportional to D? It simply means if you take the ratio between C and D, that stays as a constant. That means C over D should be equal to a constant. Or in other words, if I look at C1 over D1 for the smaller circle, that should be equal to C2 over D2 for the larger circle. No matter how many circles you consider, circumference to diameter ratio should stay a constant. So, the ancient Greeks gave that constant a label. They said C over D is equal to pi, where pi is a constant. So what is the value of pi? Well, many people attempted to find the value of pi, but they kept on getting more and more decimal places as they keep on increasing the accuracy of their methods. So simply, they kept that ratio as equal to pi. Now this pi is approximately about 3.14. Or if you would like to have a ratio, it's approximately about 22 over 7. But it is not a conclusive answer. All right, that's a separate discussion. Let's continue this discussion. Now, if I multiply this equation right here, both sides by D, I get C equals pi times D. Now, we know that diameter D should be equal to 2 times the radius, where r is the radius. Now if I replace that in this equation right here, let me label that equation as equation number 1, we get c equals pi times 2r, which we can write nicely as c equals 2 pi r. So the circumference is equal to 2 times pi times the radius, and that equation is a very important equation. Let me label this equation as equation number 2. Now we have an equation for the circumference of a circle. Now we are going to see another equation for the circumference. Think about an arc whose center is right here, and think about an arc like this. So this side can be seen as the radius. Since it is an arc, this side should also be equal to r, and this arc length s is of interest. Can you see that the arc length s should be proportional to the radius? Because if I increase the radius to be somewhere here and here, you can see that the arc length also increases. Therefore, arc length should be proportional to the radius. And also, the arc length should be proportional to whatever the angle right here. Let me label this angle as angle theta. So arc length s should also be proportional to theta. Why? Say for example, I kept this axis, x-axis as it is, and increased theta. That means, let's assume that this axis is now somewhere here. In that case also, you can see that the arc length increases for complete theta right here. Therefore, we can conclude quite easily that s should be proportional to theta as well. Now these two things can be combined, and we can write it as s is proportional to r times theta. Proportional means, once again, s over r times theta is equal to a constant. Let's assume that this constant is equal to 1. In that case, we will get s is equal to r times theta. Now think about a complete circle. For a complete circle, what is the value of theta? For a complete circle, that value of theta should be equal to 360 degrees. For a complete circle, theta should be equal to 360 degrees. Then this arc length s becomes the circumference c. All right, let's go ahead and substitute those two values. Now we have c being equal to r times 360 degrees. Now I'm going to label this relationship as equation number 3. From the earlier result, we had equation number 2 as c being equal to 2 pi r. Let me rewrite that equation. It was c equals 2 pi r. That was our second equation. We already saw that equation. Since both equations 2 and 3 have left hand side being equal to c, we can write down the right hand sides also to be equal to one another. That means we can write down 2 pi r to be equal to r times 360 degrees. Now I can divide both sides by r, and also I can divide both sides by 2. Then I get pi being equal to 180 degrees. All right, now we have a nice relationship. Pi is equal to 180 degrees. Now we will pay attention on the units. What are the units on the right hand side? We have degrees on the right hand side. What are the units on the left hand side? on the left hand side, it is just a constant. We don't have any units for that constant. In fact, when we defined pi, we defined it as the ratio between circumference and the diameter. So if you measure the circumference using feet, if you measure the diameter also using feet, feet and feet will be cancelled when you take the ratio between the circumference and the diameter. Therefore, pi doesn't have units. All right. So on this equation, on the left hand side, we have a constant which is unitless. Instead of saying it unitless always, people gave it a name. That name is radians. Now this concept is very important. Whenever you say radians, radians means no units. Whenever you say degrees, that means we have units. Okay? Remember it this way. Radians are like water. Water takes the shape of the container it has. For example, if I have to multiply a radian measure by feet, our final answer is going to be in feet. For another example, let's say I need to multiply a radian measure by inches. My final answer will be only in inches. You don't have to mention anything about radians. However, on the other hand, if you have to multiply a degree measure with feet, your final answer should be in degree feet. You cannot ignore degrees in that case. As another example, if you have to multiply a degrees measure with inches, your final answer should be in degrees inches. You cannot avoid degrees. All right, that's a discussion explaining the relationship between the radians and degrees. Thank you so much.